Hello everyone and welcome to Physics Teacher. In this grade 11U math video for functions, we are going to be going over all the basics for exponents. So stay tuned. Alright, so we're going to start by looking at some data for an exponential functions and see what their first and second differences look like. So to do that, we're going to create a new list and spreadsheet. So let's just say we're going to start, let's call this just day. Let's say we have some population data. And so let's call the first, where's the Y? There it is. Okay, and the second one we will call a pop for population. So let's just put in some sample data. So let's have day 0, 1, 2, 3, 4. And let's say the population is doubling every day. So 1, 2, 4, 8, 16. So let's take a look at those first and second differences. So I'm going to call this column just first. So and then here I can write equals. And then I'm going to click on this little book here. We're going to go down to list, operations, and then look for our difference list. And then I'm just going to type in pop because I want all the first differences of all the population. So P-O-P, enter. And there we go. So there's our first difference. First thing we'll notice is definitely not linear, because with a linear function, all your first differences are the same, and these are not. So let's check out our second differences. So let's call this one second. And then we're going to do the same thing. So equals difference list. And we're going to do the difference list for the first one. So F-I-R-R-S-T. And there you go. So the second differences are also not the same as they would be in a quadratic function. But one thing we'll notice is that when the first differences double, the second differences all double as well. They increase by the same ratio. What do I mean by that? Well, let's say the population was instead 100, 300, 900, 2700, and 8100. Notice that the first differences increase by a factor of 3. 200 to 600, so multiple of 3, and then 600 to 1800 multiplied by 3, and so on. The second differences do the same thing. 400 to 1200 multiplied by 3, 1200 to 3600, you multiplied by 3. So that's an indication we have an exponential function. So now we're going to look at an example of half-life. Now half-life is an excellent example of exponential decay. So let's say we're going to start at time 0, so 0 years have passed, and we have 1,000 milligrams of uranium-239, and it has a half-life of, let's just say, 2 years. So it's got a 2-year half-life. 2-year half-life. Okay, so that's our initial amount. So how does this work? Well, essentially, after one half-life period, which would be 2 years later, so we're going to write time in years here. So 2 years later, we end up with half of the amount of uranium-239 because the rest has decayed. So now we have half of 1,000, which is 500 milligrams. After another half-life period, which would now be 4 years later, we have half of this remaining. So that's 250 milligrams. And we just keep going. So after another half-life period, which would be 6 years, we have half of this. So that's 125 milligrams. And finally, well, that's the end of our chart. We can keep going though. After another half-life period, so that would be a total of 8 years, we have half of this, which would be 62.5 milligrams. So why is this an example of exponential decay? Let's look at what this would look like if we were to graph it. So now I'm going to show you how to do a scatter plot on our TI Inspire graphing calculator to see what this exponential decay function looks like. So we're going to create a new. We're going to go to lists and spreadsheets. So let's title our axes. The first one, let's just call that the time, which is our number of years. And for the second one, we're going to use uranium-239. So U239, that's how much is remaining. So our data was 0, 2, 4, 6, 8. And for the remaining uranium-239, we had 1,000 milligrams, 500, 250, 125, and 62.5. Now what you're going to do, we're going to add a page, so control, page, and we're going to add data and statistics, so number 5. And we're going to select our y-axis, and that's where we're going to put the uranium-239, and we're going to select the x-axis and put time. And there's your scatter plot. Pretty cool. So now we're going to figure out what a negative exponent is. So let's start with 2 to the 4 equals 16. And we're going to divide both sides of the equation by 2. Now for the side with the exponent, we subtract 1 from the exponent, and the other side we just divide by 2 normally. Let's do this again. So we're going to divide both sides by 2. So 2 to the 3 divided by 2 to the 1, subtract the exponents, you get 2 to the 2 equals 4. Let's keep following this pattern and see what we get. So if we divide by 2 again, we now have 2 to the 1 equals 2. Makes sense. Well, let's keep going. What would 2 to the 0 be? Well, divide both sides by 2, and we get 2 to the 0 equals 2 over 2, which is actually 1. And anything to the power of 0 is 1. But let's keep going and see what those negative exponents are. So if we divide by 2 again, we get 2 to the 0 divided by 2 to the 1. We subtract those exponents and we get 2 to the negative 1 is equal to a half. If we keep going and divide by 2 again, we get 2 to the negative 2 is equal to a quarter, or 1 over 2 squared. Keep going, 2 to the negative 3 is going to equal to, well, a quarter divided by half, which is equal to an eighth. Or, put another way, 1 over 2 cubed. Can you see the pattern now? Let's just do one more so you got it. So divide by 2 again, and we get 2 to the negative 4 is equal to 1 over 16, which is 1 over 2 to the 4. All right, but what do we do with rational exponents? Well, let's take 8 to the 1/3, for example. We're going to cube both sides. But on one side, we're just going to multiply it by itself 3 times. And on the other side, we're going to apply the power to the power rule, where we multiply 1/3 by 3. Then we notice that 8 to the power of 1/3 is actually just the cubic root of 8. All right, so now that we know how these fractional or rational exponents work, let's try to solve these first 2 examples up here without using a calculator. So how are we going to figure out 8 to the 2/3 without using a calculator? Well, first we can break this up into 8 of 1/3 to the power of 2, right? Because we're using our power to a power rule, so that if we multiply those 2, we get our original 2/3. Now we already know that 8 to the 1/3 is our cubic root of 8, and we have to square that. And the cubic root of 8 is 2. So 2 squared equals 4. See, not so bad. We did that without a calculator. Now let's try this one. How are we going to do this one? Well, very similar steps. Let's have 81. We're going to split this into 1/4, all to the power of 5. Now, 81 to the 1/4 is the 4th root of 81, and that's all to the power of 5. So what multiplied by itself 4 times gives you 81? Well, that would be 3. 3 times 3 is 9, times 3 again for a 3rd time would be 27, and times 3 again for a 4th time would be 81. So we have 3 to the power of 5. Then we just have to, well, we already know 3 times itself 4 times is 81, so times by 3 again, and we get 243. All right, lastly, we are going to simplify each of these expressions using our exponent laws. So just as a reminder, we have a couple exponent laws. The first one is if we multiply numbers with the same base, then we're going to add those exponents. That would be x to the 3 plus 2, which is x to the 5. If we divide these similar terms with the same base, then we are going to subtract them. So that's 3 minus 2, which is just x to the 1. And finally, just as we used above, if we do to the power of a power, so like this, then we multiply them. So that's 2 times 3, which is x to the 6th. So let's do these ones. So here we are multiplying similar bases. So we're going to add those exponents. So 2/3 plus 2/3 is going to be x to the 4/3. Then divided by x to the 1/3. So now we subtract them. 4/3 minus 1/3 is just 1. Or 3/3, which is just 1. So we're left with just x. All right, let's try this one. Here we have a power to a power. So we have to multiply them. So 2 times 2/4 gives us y to the 2/4, which we can later reduce to a half. And then over here, again, power to a power. So minus 1/3 times 2 gives us y to the minus 2/3. All right, so let's just reduce this. So this is y to the 1/2 times y to the minus 2/3. So multiplying means we have to add those exponents. So 1/2 plus 2/3. This is negative though, so let's just write this somewhere else. So 1/2 plus negative 2/3. Now you can use your calculator to figure out fractions, or we can just do it ourselves because we're not afraid of fractions. Okay, so for the first one, we're looking for a common denominator, which would be 6. Both 2 and 3 goes into 6. So for our first fraction, we're going to multiply top and bottom by 3/3. So that gives us 3/6. Positive and negative give us a negative. And for that one, we're going to multiply by 2/2 to give us that common denominator. So we have 3/6 minus 4/6, which is just negative 1/6. So this is equal to y to the negative 1/6. Which, based on what we already learned, we can rewrite that as a positive exponent. It would be 1 over y to the 1/6. Well, that's it for that tutorial. I hope it helped. If you're still here watching at the very end, I'm going to assume it did help. So thank you very much for watching. You can find more grade 11 math tutorials on functions on my playlist for my channel. I have a bunch of them, and I'll be making more as well. But also, I want to let you know, if you are taking grade 11 U Physics, you can download all of my handouts for my lessons in physics, which match with my lessons on YouTube. And you can download these for free in the description for a limited time. So go download those now, and good luck in STEM. And as always, QED.